Hello students, myself Abhishek Arora, and today we are going to discuss the topic limits. As we know from the name, we are restricting something from limits if we say. Okay. Now to understand this concept, what we take is, let us understand this by taking a circle. Okay. We have taken a circle and we have inscribed a polygon in it. Now, the area of the circle will always be greater than the area of the polygon. Of course, this is a known thing, right? But what if what I do is I break all these lines and take one line, break it from the middle, and then again make it a polygon. Fine. Something like this. Okay. What we have done here is I break all the lines and taken all these lines n times. Now what happens is the area of the circle and the area of the polygon, will they be equal? No, it will never be equal, because obviously when we are talking about a circle, we have always taken one thing into consideration, that it is always having an arc, right? And in a line, obviously एक आपके पास जब एक लाइन और एक आर्क इंटरसेक्ट करेगा तो आपके पास बीच में एक सेगमेंट बचेगा, right? So all these segments will definitely be there in the circle and the polygon which is inscribed in it, right? So which means the area of the polygon will never be equal to the area of the circle, but it will be very close to the circle, area of the circle, right? So that is what the basic concept of a limit is. Whenever we are considering a limit, okay, we can take one thing very close to the another thing. If we are saying, suppose, let us take what happens if I'm implying x approaching a, okay, it doesn't mean that x is equivalent to a. Okay, it is a very close value to a. For understanding the same concept, let us take a number line here. Okay, I've taken a number 2, right? In this number, how can I approach on the number line? Either from the left hand side or from the right hand side. There are only two possible ways to come to number 2, right? What happens is when we are approaching x from the left hand side, what we can take the value very close to, it will be 1.99999, which is not equivalent to 2, but it is very close value to 2, right? I can approximately say that okay, 1.99999 is very closer to 2. Similar thing I can do when I am approaching the same number from the right hand side. If I take the number from right hand side, what we are taking is, it is 2.00001, okay, which is again very close to 2, but it is not exactly equal to 2. So that is what the funda of the limits basically is. Whenever we are taking a number which is approaching to a particular number, suppose I am taking a variable x which is approaching a particular number a, okay, so that means the value of x can be very close to a, but it will never be equal to a, okay. So यहाँ से हमें एक और चीज पता लग जाती है, that the limit of a function will always be tending to a, okay. Suppose I take a number a which is always a finite number. We cannot take any limit which will be approaching to infinite number, okay. The answer to that number will never be equal to infinity. A limit can be approaching, but the answer of the function will never be an infinite number, okay. It will always be a finite number. So basically what we have understood till now, it is that limit can be stated as some variable which is approaching a number, जो कि आपके पास एक पर्टिकुलर वैल्यू तक पहुंच जाएगा, लेकिन उसके वेरी क्लोज रहेगा, एग्जैक्टली इक्वल टू 2 कभी नहीं हो सकता, okay. So that is what the concept of your limits is, okay. In this case we get to know about two things, okay. Here if you see, we have two particular things, that is a left hand limit and a right hand limit. Left hand limit means obviously when we are approaching a number from the left hand side of the number system, okay. And if I see from the right hand side, we are approaching the number on the number line from the right hand side direction, okay. So there are two particular limits, that is the left hand limit and the right hand limit. That is basically we are approaching a particular number from either the left hand side or from the right hand side, okay. Now let us take a few points that we need to remember here. That is, a limit of the function will never exist when there are two possible cases, okay. Either the right hand limit or the left hand limit is not defined. one of the two limits is not defined, then the overall function can never be defined. Okay, लेफ्ट हैंड लिमिट को हम डालते हैं किसी एक फंक्शन के अंदर, तो आपके पास लेफ्ट हैंड लिमिट का पर्टिकुलर आंसर आ रहा है. ओके, बट द आंसर इज नॉट वैलिड फॉर राइट हैंड लिमिट. ओके, देन आपके पास वो जो ओवरऑल लिमिट है हम उसे प्रूव नहीं कर सकते. दैट मीन्स द लिमिट विल नेवर एग्जिस्ट इन दैट केस. Okay, and the second thing, if you see here, the second is the limit of the function is always a finite number, जो मैंने आपको अभी बताया कि the answer of a limit, when you substitute that particular limit in a particular function, the answer should always be a finite number. It cannot be an infinite number. Okay, so if you see, yeah, it is very wrong statement that the answer of a limit is infinity or minus infinity. That is properly a wrong statement. Okay, now let's look at the algebra of these limits. Suppose we are having some function f. Okay, the answer to that function when we substitute a limit is L1. Okay, and there is this another function that is g of x, and the answer when we substitute a limit in it is L2. Okay, now the first thing that we know about algebra, whenever we talk about algebra, then the first thing that comes up into our mind is addition or subtraction. Okay, whenever we take the addition or subtraction of any two functions and we take the limit outside, okay, there is this limit, you have two functions which you are adding or subtracting. Okay, then this limit can be applied to both the functions separately. मतलब हम उस लिमिट को पहले फंक्शन के साथ दे सकते हैं और उसी लिमिट को हम एडिशन और सब्ट्रैक्शन के सिंबल के बाद सेकंड फंक्शन के साथ रख सकते हैं. So basically we are solving those two functions totally separately using the same limit. Okay, now we know what is the answer for the limit when we substitute it in the function. It is your L1, and the second function will give you L2, which basically gives us the answer L1 plus L2, where alpha and beta here are the constants. Basically I have taken all these constants. If you have a constant that is multiplied by the function, that constant will always come out of the limit and only the limit and the function part. Basically हम अप्रोच किसे करवा रहे हैं, हम x को अप्रोच करवा रहे हैं किसी एक नंबर पे. अब किसी एक कांस्टेंट में x तो है ही नहीं, सो उस कांस्टेंट को तो हम बाहर लेके आ सकते हैं. Then the only thing that we are left with is that the x and the function will also contain your x. ओके, तो हम उस वैल्यू ऑफ x को उस फंक्शन के अंदर सब्स्टिट्यूट कर देंगे और हमारा आंसर यहां पे हमने पहले ही एज्यूम किया हुआ है दैट इट इज इक्विवेलेंट टू L1, and the same thing goes for the g of x function. Okay, so the basic answer to the same thing whenever we are taking the addition part is we take the limit on two separate functions and solve it totally separately. Okay, then let's move on to the next part, that is basically your multiplication. Now when we are taking the multiplication part, we always follow the same rule that we have already discussed in the addition or subtraction part. Okay, हम क्या करेंगे, उस लिमिट को अगर हमारे दो फंक्शंस के साथ में मल्टीप्लाई हो रहा है तो बेसिकली दैट लिमिट विल बी गिवन टू द फंक्शन 1 एंड फंक्शन 2 सेपरेटली. दोनों को सेपरेटली सॉल्व करेंगे एंड इफ यू सी इन द रिजल्ट व्हाट हैपेंस इज L1 into L2. Right, that is the answer for your limits of the function fx and gx. ठीक है. Now see the third part, that is when we are taking the division part. अब division part में अगर आप देखेंगे it's the same thing. अगर आप पिछले दो parts में देखें तो दोनों ही parts में आपके पास the same thing will be applied. Okay, हमारे पास फर्स्ट केस में भी सेम थिंग थी, सेकंड केस में भी सेम थिंग थी, एंड द थर्ड केस विल आल्सो गेट द सेम वैल्यू provided the function g of x should have a particular value. वहां पे वो आपके पास जीरो नहीं हो सकता, as we discuss in all the rational numbers, that if you take a rational number that the denominator part can never be equal to zero. The same thing will be applied here. Okay, and next is your exponential part. Again, if you see in all these functions what we are doing, we are taking the limit separately to all the functions. So in addition and subtraction, in multiplication, in division, every part what we have discussed is we take the limit, we give it to two particular functions and then solve it accordingly, and the same will be applied in the exponential function also. If you see in the exponential function, what we have taken is the limit will be applied to the function which is underneath, and in the index part also we have taken the limit separately, solved it, and if you see the result is L1 to the power L2, which is your basic result. Okay, so in this slide what we have discussed is overall what are the basic concept of the limits. Okay, so if you have liked the video, please subscribe and stay tuned.